All right, let's dive in. Today we're looking at a huge mystery that's cost universities and students a fortune for decades. And we're going to see how researchers are finally starting to crack the code, all thanks to a very powerful, very new kind of detective: artificial intelligence. So here's the big question, the one that educators have been wrestling with for years. You have these incredibly bright, talented students who get into one of the most demanding fields out there, only for a huge number of them to switch majors or just drop out completely. What is going on? And the stakes here are massive, not just for the students themselves, but for our whole economy, which, really needs a steady stream of skilled engineers. Let's talk about the sheer scale of this, because the numbers are pretty staggering. Across the US, the national dropout rate for undergraduate engineering students is somewhere between 40 and 60%. Just think about that for a second. For every 10 students who walk into that first engineering class, 4, 5, even 6 of them won't finish with that degree. It's a massive leak in the STEM pipeline. For the longest time, figuring out why this happens has been like trying to solve a puzzle with millions of little pieces. But a recent study has brought a totally new angle to the problem, using the power of AI to finally see patterns that humans have been missing for decades. So, let's meet our lead investigator. Researchers basically unleashed a really sophisticated AI on a massive pile of student data. Its mission was simple: find out what really predicts whether an engineering student is going to stick with it and graduate. And we're not talking about a small-time operation here. The AI's case file was absolutely immense. It dug through 10 years of anonymous data from over 16,000 engineering students at a major research university. That is a huge, huge data set, which is exactly what AI needs to start finding those really meaningful patterns. The specific tool for the job here was machine learning, or ML. The easiest way to think of it is as a type of AI that's just incredibly good at detective work. You don't program it with hunches, you just feed it a mountain of information, and it literally teaches itself to spot the hidden connections and predict what's going to happen next. But here's the really crucial part. The researchers didn't just want the AI to give them an answer. They needed to know how it got there. And that's where something called explainable AI, or XAI, comes in. It's a special kind of AI that's designed to open up that black box so we can actually understand its logic. Using XAI is pretty much like telling a math student, hey, don't just give me the answer at the bottom of the page, show me every single step you took to get there. And that transparency is absolutely vital if you're going to trust the results and, actually do something with them. So, the big question: how good was this AI detective? Well, it was incredibly good. The study used a couple of different advanced models, and both of them were highly accurate at predicting which students would make it through. The AI wasn't just taking wild guesses. It was making really solid, reliable predictions. Okay, so now we know our AI detective is legit. The next question is, what clues was it actually looking at? What kind of information did it sift through to come up with its predictions? The researchers fed the AI 4 main categories of data for every single student. First, their college readiness, things like SAT scores. Second, their actual academic performance once they got to college, like their GPAs and grades. Third, their demographic background. And finally, their engagement. So did they participate in things like mentorship programs? So the AI crunched the numbers on over 16,000 student files across a full decade, looking at everything from test scores to program participation. It double-checked its own work, proved its accuracy, and now it's time for the moment of truth. What was the AI's final verdict? This is it. This is the core question of the whole study. With all the possible factors and all the variables, what did the AI flag as the most powerful predictors of who would be there on graduation day? Well, the answer turned out to be both a little surprising and incredibly clear. The single most important factor, by a long shot, was a student's early academic performance. We're talking specifically about their GPA during their first and second years in the program. It was a more powerful predictor than anything else the AI looked at. Coming in at number 2 was the student's pre-college math preparation, which was measured by their SAT Math scores. This pretty much confirms what a lot of people have suspected for a long time. Having a really strong math foundation before you even set foot on campus is a huge indicator of success in engineering. And the third major piece of this puzzle? Performance in a few specific foundational courses right at the beginning. Yep, we're talking about those notoriously tough gateway classes: Physics 1, Chemistry 1, and Calculus 1. How a student performs in those courses is a huge, huge tell. So here's a quick summary of the AI's verdict. You can see the strongest predictors were all about those early academics: GPA in the first 2 years, SAT Math, and grades in those core science and math classes. But what's really fascinating is what mattered less. Things we often focus on, like student demographics or even whether they joined co-curricular programs, they were way less predictive. The AI's conclusion is just undeniable. How a student starts is the single biggest sign of how they'll finish. So what do we actually do with this information? I mean, knowing what predicts success is one thing, but the real power comes from figuring out the so what. How can universities use these AI-driven insights to finally crack the code on student retention? Well, the most immediate application is a total game changer. It allows for the creation of an early warning system. So instead of waiting for a student to fail a class or get way behind, universities can use these models to spot the students who are at risk before they're in serious trouble, right at the very beginning of their college journey. And this isn't just about data, it's all about action. The model is really simple, but incredibly powerful. Step 1, use the AI to flag students who are showing those early warning signs. Step 2, intervene right away with targeted support. Maybe it's tutoring for that tough physics class, or some extra academic advising. The result? More students get the exact help they need, they stay on track, and ultimately, they walk across that graduation stage. And that brings us to the final, and maybe most important question this whole research project leaves us with. For decades, the reasons students were dropping out were kind of a mystery. Now, AI has given us a surprisingly clear roadmap. The puzzle isn't just about knowing who might struggle anymore. It's about deciding what we're going to do about it. The technology has given us the insight. The next step is a human one.